We've been working with absolute value equations, so now we get to move to absolute value inequalities. And we're going to solve them today in 6.6. So solving and graphing solutions. So we have a inequality in one variable. Does anybody remember how we graph an inequality in one variable? We recently were doing this, right? Does it look like, do we put it on a coordinate plane? How do you graph x is greater than 2? Remember, some of you? On a number line. We only need one dimension to do that. Unless somebody tells us that's a linear equation, we can just graph it on one number line, right? So this is kind of interesting. What value would be true here? What value could be greater than the what value, when we take the absolute value, could be greater than or equal to 2? What can we stick in there? So he says we could actually plug in -3, because what happens when we plug in -3? We get the absolute value of -3 is +3, right? So a negative could be greater than or equal to 2 when plugged in here. What about +3? If we plugged in +3, would that work as well?
Yeah.
Yes. So there's two possible things we can do here, isn't it? We can have, again, when we have absolute value symbols, I like to use two separate arrows. We could have x values being greater than or equal to 2, or we could have x values being what? Zach? You said -3 would work, right? And -3 is not greater than or equal to 2. Do you see that? So how could we write it? Anybody else? I mean, Zach, you can answer too, but I know no one has answered this yet. Nick?
Is it like x equal
Less than or equal to? -2. Excellent. Good. Okay, so with our equations, we would say x could be greater than or equal, or I'm sorry, we would say x is greater than 2 or x is less than 2, right? I'm sorry. With our equations, absolute value of x equals 2. We could say x could equal 2 or x could equal what? -2. We go two different ways with it, right? We go two different ways with absolute value as well. When we go the negative way, do you see what we do to the sign? We've got to change the sign, okay? And we end up with an OR inequality. So let's go graph the OR inequality. What type of endpoint do I have for x is greater than or equal to 2? Is that going to be open or closed? Jimmy? Good. Closed on 2. And then which direction? X's are greater than or equal to the right. These values are greater than 2, and the solid dot says it's equal to 2. And then on the other one, we have x's are less than or equal to 2. So what type of dot do we put at the -2? Closed dot. And we go which direction? To the left. Okay, so we have an OR inequality. Interesting. Okay, let's try it again with another pretty simple looking inequality. We see the absolute value, so we go two directions. Who can tell me the two inequalities? Michaela.
X is less than 1.5 and x is greater than -.
Good. Okay, so the first one looks just like the original absolute value, right? We just took away the absolute value symbol. The second one is changing the symbol to the opposite, greater than, and changing the 1.5 to its opposite. So two changes are made there, right? So let's graph it. We want to see 1.5 on this graph. We want to see -1.5. And what do you notice about this when you graph it? How can I graph this, Sophia Gimble? open dot on 1.5. What values, where would we go for less than 1.5? That's what that says, right? Left, right, less than goes this way. And then how about the other one? What type of dot there? And then where do we go for greater? To the right. So this is one of those that becomes a segment. See that? This segment has open endpoints because they are not true in the inequality. If you plug 1.5 in the inequality, 1.5 is not less than 1.5, is it? So it's a boundary, which is why we have an open endpoint there. So actually, when we have a segment like this, how could we write these two inequalities? Sophia? Good. So you can put the least number on the far left, the greatest number on the far right, x in the middle, right? And then you're right. You put your less than signs in there, right? So when we start by looking at here, negative 1.5 is less than, right, x, and that's what this says here. And x is less than 1.5. So when we have a segment like that, we can write it as one 3-part inequality. And do you think we should write it as one 3-part inequality?
Yes.
Yes, we should. Okay? If you have one that can be combined into 3 parts, you should. Is this an and or an or? Inequality? And. Okay? Interesting. So look at this. When we had a less than sign, see that? We ended up with an and inequality. When we had a greater than sign, see that? We ended up with what type of inequality? An or. So I like to say when we have absolute value, if you have a greater than next to your absolute value, greater than or, GOR, right? When you have a less than, pointing at your inequality, less than and land. You either have land or GOR, okay? And I know that sounds funny, but people remember that forever. I just asked the geometry group because they were doing some inequalities. Do you remember that less than or the greater than one? They're like, oh yeah, land GOR. So you don't have to remember it, but it could be useful, okay? So maybe you will. Okay, let's try this. Just a little bit more going on here, right? Rather than just a simple x in the inequality, in the absolute value, we have x plus 2. It's a little bit more, that's all. Okay? So whenever you see absolute value, you can draw these arrows. So you remember there are 2 we've got to deal with. And tell us the 2 we're going to deal with here, Sabrina.
X plus 2 is greater than 1.
Okay?
Then x plus 2 is less than 1.
Okay, so the greater than sign is pointing toward the absolute value. Greater. So what type of a graph do you think it'll be? Will this be a and or an or? Greater than or, GOR. So we're probably going to have a graph. Show me with your arms what it will look like. Ors are looking like that. 2 rays going opposite, right? That's probably what this is. Let's go check and see if that's what happened. So what will we do to both sides here, Sabrina?
Subtract 2.
And you get?
X is greater than -1.
And when you subtract 2 here, what do you get?
X is less than -3.
So imagine less than -3, greater than -1. Does that seem like an or? Can you visualize that? Let's graph it. And when we do, what type of dots do we have, everyone? Open. So open dot at -1. And x's are greater than -1. Which way does the arrow go? Greater than, right? And then the open dot at -3, x's are less than -3 goes, I hear you, to the left. And so, yes, greater than is an or, GOR. Okay? once again, if you have something going on outside of the absolute value, you've got to isolate and then solve. Okay? Okay, Lauren, what do we do first? Add 4 to each side, good. And does that change the sign? So absolute value of 2x plus 3 is less than or equal to 9. Okay, and now we have the absolute value isolated, so we have 2 inequalities to solve. And the first one, Lauren? Okay, and the second one? And as we look at this absolute value being isolated here, this is a less than. So a less than will be what type of a compound inequality? And, less than and, land. And so what does that look like? A segment or 2 opposite rays? It's a segment. Less than, land, and it's a segment when we graph it. Okay? And so go ahead and tell me what to do, Lauren.
So first we'll subtract the sides.
And you always are asking yourself, does that change the sign? Okay, and you have
2x is less than or equal to 6.
and so x is
Less than or equal
good. And then we have the same subtraction, but what do we have here now?
to
Negative 12, good. And when you divide now by 2, what do you have now? Good. Okay. So we said when you have a less than, you're ending up with an and. We can graph that. What else can we do with these 2 inequalities? Come on, star student, what can we do? When we have an and inequality, how do we write that? Combine them into 1 3-part, right? What do we put on the far left? The smallest number, just like a number line. Good. And then 3 on the far right. We have x in the middle, and then the signs are always less than. In this case, less than or equal to. Okay? So we graph. We need to see negative 6. So I'll use a scale of 3. And what type of point do we put at negative 6? And what type of point at 3? And x's are less than 3, okay? And x's are greater than negative 6, so yes, we got that segment that we thought we would get. Okay? Good. So let's sum this up in a rule box. Solving absolute value inequalities and or. So when we have a rule for inequalities like this, it's tough to show it in graph form, but what we could do is show the 2 inequalities that come from the original model, right? So here we have a little model. Some absolute value expression is less than c. So can somebody give us the 2 inequalities that result from this? Ax plus b could be what, Bianca?
greater than C. I mean less than C.
This sign here is a less than, so we would say less than c.
Yeah.
So we could write it that way.
And then ax plus b is greater than negative C.
Okay, so this is a less than, so it ends up being less than is an and, land, right? So we could put that in the center of the inequality. It's a segment. The value ax plus b could be less than c. Here's the original, right? Or ax plus b could be greater than negative c. And it can be combined all into 1 3-part inequality. Okay? When we have a greater than absolute value, greater than or, GOR, right? So we have our little acronym, LAND and GOR. Can we combine an OR inequality into 1 3-part inequality? No. So we're going to have two separate. So this is a little bit longer to write. And so how do we write that? Did somebody finish it? No. AX plus B is, okay, Faith?
AX plus B is greater than C, and AX plus B is less than or equal to C.
And so we have no other way to write it but two inequalities. It's a compound OR. Good job. Okay, you can pause the video, try these, and come back and check the work. And you can pause the video if you need to and look at the work that was done. For these, we were able to write this less than as a three-part, less than and land. Right? And this ended up being a less than. When we isolated the absolute value, it was still less than and land, one three-part inequality. Okay, there you go.